and last topic is eBGP. So these are the topics we'll cover in WAN. So this is the high level syllabus covered in all the topics. So today we are going to start from first topic, OSI model. So what is a model? The first question comes here is what is the model? So save this CCNA R&S session 1. Okay. Yeah. So what is the model? Model is a what is a model? Model is a representation of a process in a approach. So representation of a process in a approach. So what is the representation of the process? Now model gives what? So when you have a model gives something called standards. So what is the use of these standards? All over the world follow this, others follow the standards. Understand? Model gives standards, others follow the standards. Others follow standards. Right. Now others follow. Let us keep like this. Now think like this. Computer model. What is computer model is giving? What is computer model is giving? Computer model is giving standard. We call standard as protocols. Right? Protocols. Now these protocols are followed by who? By all computer, hardware and the software vendors. Okay. Followed by computer and hardware and software vendors. So what is the benefit of this? The benefit is benefit of OSI model is interconnectivity, connectivity of different vendors. So multiple vendors are creating same product or different product. They want to connect to each other because they all follow the same standards. They're able to interconnect. For example, motherboard wants to connect to a mouse. We use USB connector. So USB is the standard protocol. So this USB is the standard. So it is connecting to the mouse. So the mouse may be from different vendor. Motherboard can be to a different vendor. So this both can be connected because they both are following same standard or same protocol called USB. Same way, if you are using Chrome and you are trying to connect to Firefox, another PC is having Firefox. How they both are able to communicate? Because they both are using same protocol HTTP. HTTP is the protocol we use for web browsing. So because of this, HTTP is followed all over the world. Whatever application you run, Chrome or Firefox, you are able to interconnect to each other. So the benefit of OSI model is model gives standards. Standards means protocols in computer language, computer terminology, and others will be followed. So because of this, interconnectivity is happening. Now 1970, in 1970 what happened? IBM went to one organization called ISO and they asked, give me one computer model. They give OSI model. Okay. Now this OSI model, as I told you, OSI model gives what? Model gives standards, correct? So OSI model gives standard. So OSI model gives OSI protocol suites. At same time, when the IBM was going there, same time US military also went to US military also went to one organization for computer models, that is DoD, Department of Defense. They asked, can you give us one computer standard model? They gave TCP IP model. Okay. Now TCP IP model gave what? TCP IP protocol suite. Suite means multiple protocols, family of protocols. Protocol suite. Now, once we get two models, two standards, there is a big issue started. Which model will be used, which model not be used? First, they started with the model election. So between OSI and the DoD, USO and DoD model election. So first OSI model wins, TCP IP model failed. So all over the world, when we say model, we always represent in OSI model only. So, okay. Then they went for protocol election. When the protocol election happened, OSI model failed, TCP/IP model wins. Now we speak OSI model, we implement TCP/IP protocol suite. I think you can understand this. We speak OSI model and we implement TCP/IP protocol suite, right? So now we are going to first study what is OSI model. Second, I'm going to teach you 5 protocols in OSI model, TCP/IP protocol suite. In that, first is TCP, UDP, IPv4, IPv6, and last is Ethernet. So these are all the protocols we are going to study in terms. So first we'll study what is OSI model. Second, I'll explain you how to compare OSI model and TCP/IP model. Third, we'll study 5 protocols from the TCP/IP protocol suite. Okay. Next, I think everybody is clear on this. Okay, we'll go to next. Let us start from OSI model. Now OSI model, if you see, okay, OSI model, if you see, it has 7 layers. And what is the approach? The approach is layered approach. So what do you mean by layered approach? Layered approach means what? Layered approach means long communication process divided into small and simpler pieces. Long communication process divided into smaller and simpler pieces. Okay. Now, for example, you take a company example. Company, if you see, lot of things are happening in company. So what they did, they made it departments, small departments, department and functions. So what is the function of your sales department? They bring orders, purchase orders. What is the function of manufacturing department? They create products. Okay. They create products. Right? Products and services. Okay. Then what we have? Then we have implementation or engineering department. They do implementation. Then we have support team. They do management. We have network management center, network operation centers, NOC, global network operation centers, GNOC, security operation centers, SOC, like that we'll do. Okay, so these are the different. See, it's a single process, but divided into small departments. It is easy for. What is the benefit of this? So it is easy for design, develop, and troubleshooting. Okay, next we are going to see the layers. So now we have OSI layers. You see OSI layers, we have total 7 layers. What are the layers? 1, application layer. Let me write down like this. Layer 7, L7 we say. It's application layer. What is the function of application layer? User interface. 2, layer 6, presentation layer. So what is the function of presentation layer? Presentation layer function is international format and compression of data and encryption of data. Okay, right. L5, what is the function? First is what is the function? Layer, session layer, correct? Yeah, session layer. These 3 layers are called upper layers, and this is basically OS and applications. Okay, now session layer, if you see, we have function of start. Session layer function is start, maintain, and end sessions, and keep the data separate for each applications. Okay, now layer 4, we have layer 4 we have transport layer. Okay, up to layer 4, layer 3, layer 7 to layer 5 is upper layer. Layer 4 is lower layer. Okay, layer 4 we have transport layer. Function is connection oriented or connection less and reliable or unreliable communication. Then one more function is error correction. This is the only layer who can correct the error and do retransmission. Other below layers like L3, L2, L1, they can detect the error, but they cannot correct the error and retransmission. The only layer which can do this function is transport layer. Error correction and retransmission. Then L3, it's network layer. Okay, 2 functions. One is selecting the best route, that is called path determination, and logical addressing. These are the 2 functions we have in network layer. And now next layer is data link layer. Data link layer is again subdivided into 2 sub layers. It is having what are 2 sub layers? Media. One is logical link layer and another one is media access control, MAC layer. Okay, so logical link layer function is convert the upper layer, like we have packets now, packets to bytes, then bytes to frame, like upper layer to lower layer we are converting. MAC layer function is again, it has two functions. One is giving physical address, right, and second is error detection. So it is one function, error detection is happening. So like example we say CRC, FCS, all these things. Okay, now L1 we have L1 we is physical layer. In physical layer we have what is the function of physical layer is PDC, EDC, error detection code. Yeah, correct. One more. Yeah, physical layer, if you see, it will give the, it is the layer which we data actually moves host to host, what form? In bits form. Okay, then this is the one layer which gives the international standards of protocols. Standards, or we call it as protocols for cables and connectors, voltage, whatever. I'm just writing cables and connectors enough. So this is the 7-layer function. Next I'm going to teach you OSI model layers. Now, as I told you, what is the function of a model is gives protocols. Now we are going to understand OSI model. When you say OSI model, what is the protocols we are going to use? Are we going to use OSI protocols? No. So OSI model will give TCP IP protocols. Let us see what protocols fit in TCP IP protocol suite. Understand? So OSI model is not giving OSI protocols. We are going to use TCP IP protocols, but we will compare with OSI model. Okay, for example, L7 will compare with HTTP, HTTPS, FTP, like that. L6 will be discussing like what is international standard format, international format, like dot docx, dot pdf, dot mp3, everybody knows, mp4, dot mp3, and mp4. Okay, so these are the formats. And encryption format, compression format, I can tell you, like this is the formats. Compression, we have what protocols, dot zip, dot rar, and encryption format we have is encryption format is what? Yeah, so we can say like two, I'll give two protocols, like DES, triple DES is there, triple DES, and what is that? One more is RSA I can give. Okay, two protocols. Now L5, L4 okay. L5 we can have protocols like NetBIOS for Microsoft, and open standard we can use SCP, session control protocol. Then 4 is TCP IP, TCP and UDP, TCP UDP 4. L3 we have there are two protocols in that. One is path determination routing protocols, routed protocols, logical addressing protocols. Routed is IPv4, IPv6, Apple Talk, thing like that. Nowadays Apple Talk is used for Mac machines. Okay, then we have routing protocols. Routing protocols are what is that? RIP, EAGRP, OSPF, BGP, ISIS. So many protocols are there. I'm just setting this much. Okay, next we go to L2 protocols. When you say L2 protocols, there are two levels L2. One is WAN protocols, LAN protocols. So L2 LAN protocols is Ethernet, token ring, and fiber FDDI, fiber distributed data interface. Then WAN protocol is SDLC, PPP, dial-up, ISDN, and X.25, ATM, ISDN, S.25, ATM. What? Frame relay, MPLS, Metro Ethernet, cable, Metro Ethernet, Metro, and I can say like DSL, and wireless like 3G, 4G, nowadays 4G, 4G, 5G, 3G, 4G, 5G, wireless. Then we have SATCOM, satellite communication. Keeps on. A lot of protocols are there. So let us keep on writing. Okay, next is L1 protocols. L1 is understand here. L1 is cables and connectors. That you have to remember. So when you say L1 protocols, we are talking about L1 cables and connector standards. If you see the cables, what are the cables we have? UTP cable, you can say UTP cable. We can use say like Cat 5A, Cat 6, and Cat 6A, like that. And you see like connectors, RJ45, RJ45, and if you go for WAN, no, like this is LAN. If you go for WAN, we will have what? Okay, we'll keep like this. This is for LAN. Okay, if you go for WAN, we'll have V.35 connectors. Here serial DCE, DTE connector. Like that, we have so many connect cables. DCGT cables, sorry, DCGT cables. Cat 6 cable, DCGT cable. There are so many countries. I'm just holding like this. So these all are the different protocols and hope you understand this. You can give me if you have any doubts, or you can just put me in the comments. You can add the questions. I will try to reply the answer for this all your questions. Okay, and next topic we are going to study is encapsulation, OSI model encapsulation. So when you say encapsulation, what is encapsulation? So encapsulation means adding information to data. Adding information to data. Decapsulation means what? Removing information from data. Okay, now adding information, removing information. Now let us take one diagram. I'll just understand OSI model. So what we are going to add. Okay, fine. Now let us take 7 layers. So upper layer, 3 layers are there. Lower layer, 4 layers are there. Okay. Okay. Now upper layer is layer 7, layer 6, layer 4, layer 5. This is upper layers. Lower layers are layer 4, layer 3, layer 2 and layer 1. Okay. Now this layer, application layer and presentation layer and session layer. Okay. Then we have transport layer. We have network layer. Then we have data link layer. Finally, we have physical layer. As I told you, data link layer has 2 sub layers. What are they? They are LLC and MAC. Let us write down here. LLC, MAC, LLC, MAC. Okay, 2 sub layers. Fine. So now we are going to discuss about encapsulation. So when you see encapsulation, first try to understand here. We are going to see what information we are going to add with the data. So in application layer, we will be having a unformatted data. Correct? So this unformatted data is converted into formatted data. You want to do compression or encryption, you can do it. It becomes formatted data. Then you start a session. You start the communication. Start a session. Right. Now the data has to travel to another layer. For example, you want to travel from one PC to another PC. Let us copy one more site. Okay, it has to go to other PC. Think like this is PC1, PC1 and PC2. Okay, fine. PC1 and PC2. So now I am sending the data. Session layer. Now the first transport layer, it will travel. It will travel to the transport layer. Now when you start the session, the first it will go to transport layer. When you go to transport layer, the data is there. For example, this is data, your data. It will add 2 information with this. This is called encapsulation. This information, what it is adding is called L4 header. Right? So what information is going to add with the L4 header? That is source port number, destination port number. Now this data, now we call this data as a segment. What we call this as a segment. Now this information is coming to where? Yeah. So this information is coming to network layer. again data, then we have L4 header, right? L4 header. After this L4 header is reached to network layer, the network layer has to now find out the what information to be added with the data. Now he is going to add his L3 header. Okay, in L3 header we will be having source IP address and destination IP address. Source IP and destination IP. Now once you add this source IP and destination IP, okay, once you add the source IP and destination IP, you call this segment as packet. Okay, now once the packet is coming to data link layer, so the packet is coming to data link layer. So now L2, right, data link layer, it has to add its information. So it is having now L4 header and it has L3 header and it has L2 header. Okay, now this information will be comes to, and we have one more called L2 header and L2 footer. So what we are adding? L2 header and L2 footer. So what we add in L2 header and L2 footer? In header we add source MAC address, destination MAC address, and footer we add CRC like FCS or EDC, like error detection. Now these informations once you add, we call this as a frame. Now this frame is converted into 0 1 1 0 1 0 0 0 1 0 0 1 1, like this is converted into bits. So this is called bits. So this information, so I told like one segment, packet, frame, bits. These all are called what? This is called protocol data units. What we call this? Protocol data units. Fine. So this is called encapsulation. Now before sending the data in PC1, I am sending the data to adding all this information for, and I am sending in the wire. Now the data is traveling from PC1 to physically traveling to PC2. Once it reaches to PC2, what PC2 will do? PC2 will remove one by one. He'll use the information and remove one by one. Finally, he will give the data. Understand? Finally, you will reach like this. It will go one by one. It will be removed. Finally, it will give the data. So, do you understand what is encapsulation and decapsulation? Okay. So, this is called the data flow between two PCs based on OSI model representation. I think hope it is informative for you. And if any doubts, we will discuss on. You can put it in the comments. We will discuss. I'll try to reply. And you can come for our next meeting. You can attend the next online class, so we can discuss on the topics also. So we have covered OSI model. In OSI model, we discussed about 3 things today. First is what is a model, we discussed. Then we saw about the 2 types of model, which organization developed the model. Then we went to what is OSI model. OSI model has a layered approach, right? What is layered approach? I explained you. Then I went through the OSI layers. In OSI layers, what is the layer? Every layer, and what is the function of the layers? I explained. Layers function. OSI layers and their functions we discussed. Then we discussed about the which layer, which protocols will come, like compared to TCP/IP model protocol suite. Which layers, which protocols will come, that we discussed. Then we went through the what is encapsulation and decapsulation. I think we can stop with this today. We will try to finish it. So next class we'll be covering some other things like port address, session layer, little bit details on session layer function, port address on this. So see you on the next class. Take care. Thank you. Bye.